Chapter 11, Congruence of Triangle, I Enrich 2. Before solving that, subscribe to Mohanraj Ganapati and share it with your friends. So first sum, if triangle LMN is congruent to triangle XYZ, let us draw the triangle LMN and XYZ. I have named in anti-clockwise. Same manner you can follow. Since they have mentioned LMN and XYZ. Look at the vertices first. L is corresponds to X, M is corresponds to Y, and N, this is N corresponds to Z. Is it clear? L corresponds to X, M corresponds to Y, and N corresponds to Z. L corresponds to X, M corresponds to Y, and N corresponds to Z. Okay, we are seeing about the vertices. What about the angles? Same. Angle L is correspond to angle X. Angle M is correspond to angle Y. Angle N corresponds to angle Z. Okay. What about the sides? You have to mention about the sides also. So LM is correspond to XY. MN corresponds to YZ. NL corresponds to YX. Not YX, it is ZX. Is it clear? Okay. Second sum. In triangle ABC and triangle XYZ, first draw a triangle. Whenever you draw a triangle, the sum becomes very easy to you. X, Y, Z. Okay. They have given some condition. Mark that too in the triangle. Okay. AB is equal to XY. AB is equal to XY. Okay. AC is equal to XZ and BC is equal to YZ. Okay. This follows side congruence. Okay. Write all the corresponding congruent vertices of both the triangles. Corresponding vertices. They are asking about the vertices alone. Vertices. A corresponds to X, B corresponds to Y, and C corresponds to Z. Third sum. Identify the congruence condition and write the congruence rule in symbolic form. First sum. Let I split the triangle into two. G, F, I. Okay. I am drawing the second triangle with respect to the first one. G, I, H. Now, for comparison, it is very easy. FG is equal to 3H. Angle G, that is angle FGI, is equal to angle HGI. Okay. And GI is equal to GI. Okay. So what type of congruence it is? Side angle side. Side angle side congruence. Triangle FGI is congruent to triangle HGI. Clear? B. Let us split the triangle into two parts. So diagram into two parts. S, R, U. I am drawing the second one in terms of the first triangle. S, T, U. Okay, there is a common angle between them, or a side, we can say it as a side. Angle, side, angle. So compare. Angle S is equivalent to angle S. T. I will circle what are the equal. This angle is equal, this angle is equal, and this side is equal. So two angles and one side. So angle, side, angle congruence. Triangle, we can name RSU is congruent to triangle TSU. Is it clear? See, same thing. I'm going to split the triangle diagram into two. J, K, M. Here there is a slight variation. L. Look at the angle. L, M, K should be there. Okay. See, J, K, M. Angle M is given. Angle J is given. Again here angle L is given and angle K alone is mentioned. So I have rewritten the diagram like this. Redrawn the diagram like this. Don't confuse. Okay. So there is a common side between them. Angle, side, angle. So two angles is common. JL and MK are similar. There is a common side between them, which is angle, side, angle. So angle, side, angle congruence. Triangle KLM MJK. Triangle KLM congruent to triangle MJK. Is it clear? Shall we move on to the next sum? Okay. D. Splitting the diagram into two. NPO. NPQ. ON is equal to QN. Angle N is similar and common side is there. NP. So side, angle, side congruence. Side, angle, side congruence. ONP. Triangle ONP is congruent to triangle QNP. Side, angle, side, QNP. Okay, either way you can write, or you can also write NPO is congruent to NPQ, or NOP is congruent to NQP. Okay. E. Parallelogram, splitting the parallelogram into two. Triangle J, K, M. L, K, M. L, M is equal to JK. Angle M is equal to angle K. M, K is common side. Side, angle, side. Side, angle, side. Triangle K, L, M is congruent to triangle M, J, K. K, L, M is congruent to triangle L, congruent to triangle M, J, K. F subdivision. EBAC, angle A given, B D, sorry, E should be there, EDC, angle D is mentioned, ED is given. Okay, is there any common side? You can take AC as a common side. Angle, side, angle. C is a common side, so angle C can be taken, or angle B and E. Angle, side, angle. Triangle ABC is congruent to triangle DEC. Okay, that's completed. Fourth sum. In the given figure, show that triangle ABC is congruent to triangle EDC. First, let us split the diagram into two. A, B, C. I am inverting and drawing the another diagram. CDE, because of the angle. Here it is 50, D is 50, C80, AB 4 centimeter, ED 4 centimeter. So ABC is congruent to EDC by what? Angle, side, angle. AB is equal to ED, angle ABC is equal to angle EDC is equal to 50 degree, angle ACB is equal to angle ECD is equal to 80 degree. Therefore, by angle, side, angle, triangle ABC is congruent to triangle EDC. Fifth sum, in triangle ABC and triangle DEF, ABC triangle DEF, both are isosceles. AB equal to AC, AB equal to AC, DE equal to EF. If AB equal to DE, AB is equal to DE, and BC is equal to EF. BC is equal to EF. AB is equal to DE. Okay, redrawing the diagram with the second condition. ABC, BC is equal to EF. AB is equal to DE, BC is equal to EF. Okay. DE is equal to, already DE is equal to EF, and AB is equal to AC. AB and AC are equal. Therefore, DE and DF is also equal. Therefore, by side criterion, triangle ABC is congruent to triangle DEF, because vertices A corresponds to D, B corresponds to E, and C corresponds to F by vertices. You can also say like that. And then state the criterion of congruency. Yes, the triangles are congruent by the side congruency. If angle B is 50 degree, what is the measure of E? 50 degree. Since B corresponds to E, angle E is equal to 50 degrees. Angle B corresponds to angle E, therefore angle E is equal to 50 degrees. Sixth sum, in the given figure, AD is parallel to BC, AB is parallel to DC. Verify triangle ADC is congruent to triangle CBA. ADCB equal DCBA. AC is a common side by SSS criterion, that is AD corresponds to BC, AC corresponds to CA, and DC corresponds to BA. Therefore, triangle ADC congruent to triangle CBA. B subdivision. Which angle is equal to ACD? ACD is equal to angle CAB. Look at this. ACD, CAB. C. Which angle is equal to ACB? ACB. ACB. A. Yes. Angle ACB is equal to angle CAD. Is it clear? ACB is equal to CAD or DAC. Both are right. Seventh sum. Show that triangle PQR is congruent to triangle TSR. PQR. I am drawing the second one in the same manner. R. T. Yes. 55 degree. QR 3 centimeter. RS 3 centimeter. Okay. Angle P corresponds to angle T. QR corresponds to SR. QR corresponds to SR. So what is the common thing? QP is equal to, you can take anything, since one angle and one side is given, we can take R as a common angle by ASA, angle side angle. Triangle PQR is congruent to triangle TSR. Eighth sum. Draw a right angled triangle PQR using RHS, right hypotenuse side criterion. Construct another triangle XYZ. Draw a right angle triangle. I am drawing it roughly. You can use scale and pencil. PQR is 90 degree. Angle Q is 90 degree. Using the RHS criterion XYZ. X, Y, Z, which? Okay. P corresponds to X, Q corresponds to Y, R corresponds to Z, PR is hypotenuse, which corresponds to XZ. QR corresponds to YZ, which is a side. Angle Q corresponds to angle Y, which is a right angle. Ninth sum. In the given figure, AM bisects BAD. AM bisects, which means it divides that figure into two equal halves. A, B, C. A, D, C. Angle A, A, C is mentioned. Four angles are equal. Angle A is equal to, that is angle BAC is equal to DAC. Angle BCA is equal to DCA. Verify the triangle ADC is equal to, by angle side angle, by angle side angle, that is angle BAC corresponds to angle DAC. Angle BCA corresponds to angle DCA. Angle A side AC is corresponds to AC. Therefore, triangle ADC congruent to triangle ABC. 10th sum. State if the given pair of triangle are congruent. Also state the condition of congruence satisfied. One right angle is given, so obviously angle D is also a right angle. ABC, EDC. This angle A and angle E are corresponding to each other. AC is the common, hypotenuse, as well as EC is a hypotenuse here. So angle B is 90 degree, then angle D is also 90 degree. By RHS criterion, that is angle A corresponds to angle E, angle B corresponds to angle D, AC is hypotenuse which corresponds to EC. Therefore, BC corresponds to DC. By right angle hypotenuse side criterion, they are congruence. Given figure is congruent. Given figure is congruent. 11th sum. In the given figure, PQ equal to QR. PQ equal to QR. And PQS is equal to RQS. Show that. Okay. Angle P corresponds to R. Let us draw the triangle first. PQS. PQ is equal to QR, right? QR. QS. Okay, RQ is equal. Since SQ is common to both the figure and angle Q is given. Okay, from this we can conclude triangle PSQ is congruent to triangle RSQ because PQ is equal to RQ, that is PQ corresponds to RQ. QS is common side. angle SQP is corresponds to angle SQR by side angle side triangle PSQ is congruent to triangle RSQ. 12th sum. In the given figure, AP and RQ intersect at the point O. Show that ARO is congruent to triangle PQO. ARO congruent to triangle PQO. 55 degree. Angle Q is 55 degree. AO 2.5 centimeter. PO 2.5 centimeter. O by angle side angle, that is angle R corresponds to angle Q. Angle AOR corresponds to angle POQ. AO corresponds to side AO corresponds to PO. Therefore, triangle ARO congruent to triangle PQO. With this, chapter 11 Congruence of Triangles I Enrich 2 is completed. If you like the video, share it with your friends. If you have any doubt, comment in the comment section. Don't forget to subscribe. Mohanraj Ganapathy. Keep supporting. See you in another video. Take care.